The simplest series circuit will consist of a battery and a resistance. You could solve for the current through the circuit by using Ohm's law. Resistance is equal to voltage divided by current. You could rearrange the equation so current is equal to voltage divided by resistance. You know the total voltage of the circuit, which is 5 volts at the battery. The total resistance is 5 ohms provided by the single resistor. So the current is equal to 1 amp. The current at the voltage is 1 amp. The current at the resistor is 1 amp because this is a series circuit. How do you know? At the battery, the long plate is high potential positive. The short plate is low potential negative. Current flows from high to low. So in this case, it is flowing counterclockwise. If you notice, there's only one possible path or one loop. Therefore, it is a series circuit. In a series circuit, the current is constant. So if the current at the battery is 1 amp, then the current at the resistor is also 1 amp. This is another series circuit. If you look at the battery, the long plate is high potential, positive. The short plate is negative, low potential. Current flows from high to low, so the current will flow in clockwise direction. Since there is only one path possible, this is a series circuit. If you look here, all the resistance are given. If all the resistance are given, the first thing you want to do is find the total resistance. Total resistance in a series circuit is equal to all the resistance added together. So in this case, there are 3 resistors, so it's R1 plus R2 plus R3, which is 10 ohms, plus 20 ohms, plus 30 ohms, which is equal to 60 ohms. So the battery has 60 ohms. Once I find the total resistance, I want to solve for the current if possible. The total current is going to equal to I total is equal to V total over the R total using Ohm's law. The voltage total at the battery is 10 volts. The total resistance is 60 ohms. We just solved that. Divide the two, and you get 0.167 amps. Since the current at the battery is 0.167 amps, and this is a series circuit, the current is going to be the same because the current is constant in a series circuit. So the current at I3 is going to be 0.167 amps. The current at R2, I2 is also going to be 0.167 amps. And at R1, I1 is equal to 0.167 amps. If you notice, now I have I and R, so that means I could find the voltage for each of the resistor. Using Ohm's law, V1 is equal to I1, R1, which is equal to 0.167 amps times 10 ohms, which is equal to 1.67 volts. V2 is equal to I2 times R2, which is equal to 0.167 amps times 20 ohms, which is equal to 3.34 volts. We can solve for V3 using I3 times R3, which is equal to 0.167 amps, times 30 ohms, which is equal to 5.01 volts. So if you notice, the voltage at R1 is 1.67 volts, at V2 is 3.34 volts, at R3 is 5.01 volts. The current is all the same because it is a series circuit and current is constant in a series circuit. We could double check the voltage by adding all the voltage together. Why? In a series circuit, the total voltage is the sum of all the individual voltage. That means all the resistor voltage must equal to the battery. So V total is going to be V1 plus V2 plus V3. So V1 is 1.67 volts plus 3.34 volts from V2. V3 is going to be 5.01 volts. If I add this is approximately 10.02 volts. It's a little bit over the 10, which is at the battery, because we are dealing with decimals. So what is going on in the circuit? The current is flowing from high to low. 10 volts enters resistor 1 here. The resistor 1 uses 1.67 volts. So when the voltage leaves resistor 1, we only have 8.33 volts. So there's a voltage drop of 1.67. 8.33 volts enters resistor 2. Resistor 2 uses 3.34 volts. So the voltage drops 3.34 and only 4.99 volts is left over. 4.99 volts enters R3. We use approximately 5.01 volts. So by the end of the entire circuit, we will end up with approximately 0 volts. This is why V1, V2, V3 are known as voltage drops. This circuit is similar to the problem we just finished. Pause the video, solve the circuit on your own, and check your answers. This is also a series circuit. The long plate is high potential, the short plate is low potential, so the current will go from high to low by convention, so it's going to go clockwise. If you notice, there is only one path the current could travel through, so this is a series circuit. Just like the previous problem, if you notice, all the resistance is provided. When the resistance is provided, the first thing you want to do is solve for the total resistance. Total resistance in a series circuit is R1 plus R2 plus R3. So this is equal to 20 ohms plus 20 ohms plus 40 ohms, total of 80 ohms. So there's 80 ohms at the battery. Since we know the voltage and current, or the voltage and the resistance, find the total current. The total current using Ohm's law is voltage total divided by resistance total. The voltage total is provided by the battery, which we know is 20 volts. The resistance total, we just calculated, is 80. So 20 divided by 80 is 0.25 amps. So the current at the battery is 0.25 amps. Since this is a series circuit, all the currents are 0.25 amps. So I1 is equal to 0.25 amps. I2 is equal to 0.25 amps. I3 is also equal to 0.25 amps. Why? Current is constant in a series circuit. Since I know I and R at each of the resistor, I can find the voltage at the resistor, or the voltage drop. V1 is equal to I1 times R1. I1 is 0.25 amps times 20 ohms, which is equal to 5 volts. V2 is equal to I2 over times R2. This is equal to 0.25 amps times 20 ohms. So this is also equal to 5 volts. V3 is equal to I3 times R3. So it is 0.25 amps times 40 ohms. So this is equal to 10 volts. The voltage is 5, 5, and 10. We could double check the total voltage because the total voltage across the resistor has to equal to the voltage of the battery. So V total is equal to V1 plus V2 plus V3. So this is 5 volts plus 5 volts plus 10 volts, which is 20 volts, which equals the battery. So again, what is happening? 20 volts enter the first resistor, 5 volts is used, or there's a voltage drop of 5, so 15 leaves. 15 enters R2, there's a voltage drop of 5, so 10 volts are left over. 10 volts enters R3. R3 has a voltage drop of 10 volts, uses it. So at the end of R3, there's 0 volts left. This next slide is slightly different from the previous problem because the voltage is provided at the battery. However, all the resistance are not provided. If all the resistance are not provided, the first thing you're going to do is see if you can find the current. If you find the current and it's a series circuit, you know that the current is going to be the same throughout. So we know this is a series circuit again because the long plate is high potential, short plate is low potential. Current flows from high to low, so it's going to go clockwise. If you notice, there's only one loop that the current could travel through, so this is a series circuit. Since I2 is given as 1 amp and this is a series circuit, I is constant. So that means I1 is equal to 1 amp. The battery is equal to 1 amp, or the total. And I3 is equal to 1 amp. So these are all equal to 1. So now I could solve the resistance at the battery because R total, according to Ohm's law, is V total over I total. V total is 30 volts. I total is 1 amp. So the total resistance is 30 ohms. I could solve for V1 using Ohm's law because V1 is equal to I1 times R1. So that's 1 amp times 10 ohms, which is equal to 10 volts. I could solve for V3 because I know I3 times R3, which is equal to 1 amp times 5 ohms, which is 5 volts. So I know V1 is equal to 10, V3 is equal to 5. So now I could either solve for the voltage first for R2 or the resistance. So first way I'm going to do it, first method is I'm going to solve for the V. We know in a series circuit, the voltage adds up to the battery. So V total has to equal to V1 plus V2 plus V3. The battery has 30 volts. V1 has 10 volts. Plus V2 plus V3 is 5 volts. Therefore, V2 must equal to 15 volts. Since we know the voltage at V2, I could solve for R2, because R2, according to Ohm's law, is V2 over I2. V2 is 15 volts. I2 is 1 amp. So this has to be 15 ohms. We could start with the total resistance and solve it the second way. We know in a series circuit, R total is equal to R1 plus R2 plus R3. We know that the total resistance is 30 ohms. This is equal to R1, which is 10 ohms, plus R2 plus R3, which is 5 ohms. That tells you that R2 is equal to 15 ohms. So I could solve for V2 because I know I2 times R2. So this is 1 amp times 15 ohms, which is equal to 15 volts. If you notice, either way, you'll get the same answer. This problem is similar to the previous problem, so please pause the video, work the problem out, and check the answer. This problem is similar to the previous problem. All the resistance is not given. So what you want to do is try to solve for the current first, if possible. Because in a series circuit, the current is constant. If we know the current at one of the resistors, we know the current at all the resistors and battery. We know this is a series circuit because at the battery, the long plate is high potential, the short plate is low potential. By convention, current flows from high to low. Since there is only one path the current could travel through, this is a series circuit. So if I look at R3, the voltage is given. Since the voltage and resistance is known, I could use Ohm's law to solve for the current I3, which is V3 divided by R3, which is 10 volts, divided by 5 ohms. This is equal to 2 amps. Since I know the current of I3 is 2 amps, and we know this circuit is a series circuit, the current at R2 is equal to 2 amps. The current at R1 is equal to 2 amps. The current at the battery is also equal to 2 amps. So now I could solve. I could solve for the battery because the battery is going to equal to I total times R total, which is equal to 2 amps times 30 ohms, which is equal to 60 volts. I can't solve for R1 yet. I have 2 unknowns. So I'm going to move on to V2. I can solve for V2 because I know I2 times R2 will give me the voltage, which is 2 amps times 10 ohms, which is 20 volts. So I could fill my table in. This is 60 volts. I know this is 20 volts. I also know the currents are all 2. So now I could solve for R1. Similar to the previous problem, I could solve the voltage first and then solve the R, or I could solve for the R and then the voltage. So I'm going to do it both ways. Method 1, I'm going to solve for the voltage first. In a series circuit, the voltage total is equal to the voltage of the individual resistance. So V total is 60 volts. This is equal to V1, which we don't know, plus 20 volts of V2, plus 10 volts of V3. So V1 has to equal to 30 volts. I could solve for R1 because R1 is going to be V1 divided by I1, which is 30 volts, divided by 2 amps, which is 15 ohms. I could solve for the R first, the second method, because in a series circuit, R total is equal to R1 plus R2 plus R3. So R total is 30 ohms equals to R1 plus R2, which is 10 ohms, plus R3, which is 5 ohms. So R1 has to equal to 15 ohms. So that means I could solve for V1, which is equal to I1 times R1, which is 2 amps times 15 ohms, which is equal to 30 volts. So if you notice either method, the answer comes out the same. Here's another series circuit. Pause the video, solve it, and check your answer. So this example is similar to the previous two because all the resistance are not given. So again, when the resistance are not given in a series circuit, you want to see if you can solve for a current. Because if you solve for a current, current is constant, so all the other parts will have the same current. We know this is a series circuit because the current can only flow in one path. It's going to go high potential to low potential, so there's only one path. We know the current is 1 amp at the battery because that was given. Since this is a series circuit, the current at I1 is 1 amp. At R2 is also 1 amp. And I3, or at R3, is 1 amp. So I could solve for my voltage at V1 because I know the current and resistance. I1 times R1 is equal to 1 amp times 15 ohms, which is equal to 15 volts. I could solve for V2 because I2 times R2 is equal to 1 amp times 10 ohms, which is 10 volts. I could solve for R3, which is V3 over I3 is 5 volts divided by 1 amp. This is equal to 5 ohms. So if I fill my table up, V1 is 15, V2 is 10, R3 is 5 is given. All the currents are 1. And I know I could solve for the resistance at R3, which I solved as 5. So I could solve for V or R. It really doesn't matter. You need to solve for one and you could use the Ohm's law, or you could just use the series rule and solve for both. So in a series circuit, the voltage total is equal to the voltage of the individual. The voltage drops. So this is going to be 15 volts plus 10 volts plus 5 volts. So this is going to be 30 volts. You could use Ohm's law if you want at this point to find R total, which is V total over I total. This is 30 volts divided by 1 amp, which is 30 ohms. Or you could have done R total is equal to R1 plus R2 plus R3. And we know R1 is 15 ohms plus 10 ohms plus 5 ohms, which is also 30 ohms. And so again, what is happening? We start with 30 volts from the battery. So the battery has 30 volts. 30 volts enters R1. There's a voltage drop of 15 volts. So 15 volts leave. R1 uses 15. 15 volts enters R2. There's a voltage drop at R2 of 10. So we have 5 volts that leaves R2. 5 volts enter R3. 0 leaves, and that is what you want. This potential difference is what causes the circuit to push the current through. Complete the circuit by solving the missing variables and then check your answers. This is a series circuit. The high potential is the long plate. The low potential is the short plate. The current will flow from high to low. So it's flowing counterclockwise by convention. Since there is only one path or one loop, this is a series circuit. If we know the current in a series circuit, we know the current is going to be the same throughout the entire circuit. If I check I5, I5 is given as 3 amps. Since the current is 3 amps at resistor 5, the current is going to be the same at all the resistor and the battery. So that means I1 is also 3 amps. I2 is also 3 amps. I3 is also 3 amps. I4 is also 3 amps. And the battery I total is also 3 amps. So we're going to solve for the total resistance, because total resistance equals the total voltage over I total. The total voltage at the battery is 40 volts. The total current is 3 amps. So total resistance is going to be 13.33 ohms. Now I could solve for V1. V1 is I1 times R1, which is equal to 3 amps times 2 ohms, which is equal to 6 volts. I could solve for R2. R2 is going to equal to V2 over I2, which is 5 volts, divided by 3 amps, which is equal to 1.67 ohms. I could solve for V3, because V3 is going to equal to I3 times R3, which is equal to 3 amps times 5 ohms, which is 15 volts. I could solve for R4, because R4 is going to be V4 divided by I4, which is 10 volts divided by 3 amps, which is approximately 3.33 ohms. And I could solve for R5 if I know V5. And so how do I solve for V5? Let's fill the rest of the table up. I know R1 is 6 volts. I know R3 is 15 volts. R4 is 10. R5 voltage, we don't know. R2 is 1.67 resistance. R4 has a resistance of 3.33 ohms. So since this is series, I could solve for the voltage, then solve for the R, or I could solve for the R, then solve for the voltage. So I'm going to solve for the voltage first. So I know V total at the battery has to equal to V1, V2, plus V3, plus V4, plus V5, which is all the resistance. So this is 40 volts. V1 is 6 volts. V2 is 5 volts. V3 is 15 volts. V4 is 10 volts plus V5. So V5 is 4 volts. So I could solve for R5 because it's going to be 4 volts divided by the current which was given, 3 amps, which is equal to 1.33 ohms. The other way I could do that is, since all the resistance must add up to the total resistance, we know R1 plus R2 plus R3, R4, R5. Our total is 13.33 ohms. R1 is 2 ohms. R2 is 1.67 ohms. R3 is 5 ohms. R4 is 3.33 ohms plus R5. R5 is equal to 1.33 ohms. So V5 is equal to I5 R5. This is 3 amps times 1.33 ohms, which is equal to 4 volts. Either way, it works. Here's a quick summary on series circuit. If all the resistance and total voltage is given, solve for the total R, or R equivalent. After you solve for the total resistance, solve for the total current using Ohm's law. Voltage total, which is the battery, divided by the total resistance. Once you find the I total, we know in a series circuit the current is constant. So the current at the battery, the current at resistor 1 to resistor 100, if it's connected in a series, they will have the same value. If only a few of the resistance is given, see if a current is given in one of the resistors or the battery. If the current is given, you know in a series circuit, it is constant. So every part of that circuit will have the same current. If the current is not given, solve for the current. That means either the resistance or voltage is given. So using Ohm's law, V is equal to IR. Solve for the current. Once you know the current is constant and you know the value for it, it is much easier to solve for a series circuit.